Alright guys, remember when we were working on fractional polynomials or rational polynomials, we had to treat them with the same concept as fractions. So we know that we couldn't simplify a fractional polynomial if the denominators were not the same. So we had to find an LCM. And we learned that the LCM would be the unique factors in the denominator. So we see that this has a factor z minus 2, and this has a factor z plus 2. So in order for us to make them the same LCM, we would have to combine the unique factors in each denominator. So this is z plus 2 and z minus 2 and z plus 2. All right. And then now we have our new denominator, z minus 2, z plus 2. We have to multiply our numerator by the missing factor of the LCM. So here, if we go back to our original term, we see the factor z minus 2 is in it, but when we look at the LCM, it's missing the factor z plus 2. So that's what we'll multiply our numerator with in order to make our fraction equivalent. So now our new expression at the top would yield 16z plus 32, right? Because I did distributive property. And then we look at our other term, we see the missing factor is z minus 2 from the LCM. So we'll multiply the numerator here by z minus 2. And applying the distributive property, now we have plus 16z minus 32. All right. So now we can operate on our fractional expression here, where we can combine like terms, and we see up here is 32z. And we see that we have two terms of same quantity and opposite signs, so that's a subtraction is left with 0. So your end answer here would be just be 32z and z minus 2 times z plus 2. You can leave this in factored form. I know some of you might be tempted to distribute it, and if you look at it carefully, you can see it's a difference of 2 squares, but you don't need to do all of that. You can just leave it in factored form. Now, the reason why I just brought this up back is because now you'll see them in the form of an equation. So you'll have an expression like an equation that says to solve, you'll have 16 over z minus 2 plus 16 over z plus 2 equals to 6. Again, these are fractional equations, so the rule of LCM is still taking into place. I'll put that 6 over 1. So like I showed previously when it was an expression, my LCM here is z minus 2 and z plus 2. The beauty about equations, though, you see like how when I had my expression, I was left with the LCM and I was multiplying the numerator by the missing factor in the LCM, like what I did earlier, right? In this case, when doing equations, I multiply every term on both sides of the equation. Right, I multiply every term on both sides of the equation by the LCM, whatever that is. So here is what I'll do. I'll say z minus 2 times z plus 2 times 16 over z minus 2 plus z minus 2 times z plus 2 times 16 over z plus 2. Right, equals 6 times z minus 2 times z plus 2. So here what happens, the beauty about this is that you get to cancel out the denominator. So I see they have a common factor of z minus 2, so I'm just left with z plus 2 times 16. And when we distribute that, we get 16z plus 32. Here I see they have a common factor of z plus 2. And we're left with the factor 16 and z minus 2. So I have plus 16z minus 32 equal. Now I'm going to have to distribute everything here. Now here is where it comes in handy to do a distribution. And we see clearly that that's a difference of 2 squares. So we can work that out. So now I can distribute. And I have 6z squared minus 24. Great, and we see potentially we have a quadratic equation being formed here. So now let's transpose all our terms, because quadratic equations must be equal to 0, and then combine like terms, or you could combine like terms and transpose. It doesn't matter. The idea is that we have to solve for z. All right, so here we go. I'm going to transpose all terms, and I'll do that by keeping like terms together. Equals 0. Here we go. So now here I have 32z. This cancels out, minus 6z squared plus 24. So potentially, you see what's happening here? It looks like my leading coefficient, which is 6z squared, will be negative. We don't want to work with negative, so we're going to divide everything by -1. So my new equation will look like this. I'm just going to go up here, guys. So this was my equation before. 32z minus 6z squared plus 24 equals 0. Divide everything by -1, because I'm going to put this in order of hierarchy eventually, which will show that my leading coefficient is going to be a negative, and we don't want to work with negative. So now everything now is going to be the signs will change. All right, remember, equations, what you do on one side, you must do on the other side. Even though we know the result will be 0, we're still keeping it in its technical form. Plus 6z minus 24 equals 0. Put it in order of hierarchy. All right, also, what are we seeing here? We're seeing that there's a common factor of 2 in all of these expressions. All right, here we go in the expression over here. So I'll be left with, if I divide everything by 2, I'll be left with 3z squared minus 16z minus 12 equal to 0. All right, so that's my equation that I'll have to solve. Let's see what happens. Okay, so I'm going to use my AC method here because my leading coefficient is not 1, so I can't just look at my end term and decide what my two factors are. And if you can, good for you. So this is 3 times 12, which will give me negative 36. So because I have a negative AC, it means I'll have to do a subtraction to find my middle term. And it also means that I'll have a negative and positive factor to give me a negative n factor. So it looks like 18 and 2 would be appropriate, because if we subtract 18 and 2, we'll get negative 16. But you see what I did here? I made 18 positive and 2 negative. So what do you see wrong with that picture? I hope you see that if I subtracted this positive and this negative, it'll give me a positive 16. So actually my bigger factor should take the sign of the middle. So if I subtract these two factors now, it'll give me negative 16. So here we go. Let's take our trinomial and now make it into 4 terms so we can factor by grouping. And then now I'm going to, by default, form 2 groups and then factor the individual groups. So here I have a common factor of 3z, which leaves me with z minus 6. And here I have a common factor of 2, which leaves me with z minus 6. And I know I'm on track because now I can see I have a GCF of z minus 6 that I can factor out. And my remaining factor is 3z plus 2. Now I'm going to set my individual factors, as we remember, to 0 and solve for z. So I have z equals 6 and z equals negative 2/3. All right, then let's try another one. Good, so now here we have the equation x over x minus 2 plus 1 over x minus 4 equals to 2 over x squared minus 6x plus 8. So what we see having here, we see we have a unique factor of x minus 2, another unique factor of x minus 4, but here Here, we'll have to factor this in order to see what the two unique factors it would produce. And if you look at it, my C, my constant is 8. And I know I can positive 8. So I know I can find two negative factors that will give me positive 8. And when I add them, it'll give me negative 6. And you guessed right, that will be 4 and 2. 4 times 2 is negative 4 times negative 2 is positive 8. And if you add them, you'll get negative 6. So here we see that it has the factor x minus 2 and x minus 4. So it looks like our LCM, we only choose it once, is x minus 2 and x minus 4. And now I'm going to multiply all my terms by the LCM so I can get a nice linear looking equation and then solve for x. So let's get to work. So another way you can shortcut this is that you can see, if you look at the original expression here, term here, what factor is missing from the denominator? So here we have x minus 2, but the LCM is x minus 2 and x minus 4. So it looks like the factor x minus 4 is missing. So obviously, if I was to multiply this LCM by this, I'll be able to cancel out the common factor of x minus 2, and I'll be left with x minus 4. So if you can see that by hindsight, you could just jump to the chase and just say this is x times x minus 4 plus what's missing here, x minus 2, 1 times x minus 2. And then if you look at this one, this looks like if I multiply the term by my LCM, I'm able to cancel the entire thing. Cancel, cancel. So I'm just left with 2. All right, now I have my nice linear looking equation that eventually will look into a quadratic equation once I do some distribution. I'm going to transpose my 2, make it equal to 0. And then I'm going to combine my like terms. And now I can factor this equation because the leading coefficient is 1 again. It makes life beautiful. So my C is a negative 4. That means it has to be a positive, a negative factor that when I multiply, I get negative 4. And I'll have to subtract to find my middle. And that looks like 4 and 1. So it'll be x minus 4 and x plus 1. And remember, if I'm to subtract, you usually keep the sign of the higher magnitude. So that means the bigger factor takes the sign of the middle. Now I'm going to set each factor equal to 0 and solve for my x's. So here we go. X is equal to 4 here and x is equal to negative 1. It's beautiful. Let's do one more. All right, so here we have a fractional equation of x over x minus 1 equals to 8 over x minus 2. Now, what I like about this type of equation is that it's a proportion, or it's proportional. When we talk about proportional is when we have one fraction equaling another fraction. And what I like about these types of problems is that you can cross multiply to solve. Oh yes, deliciousness. So here we go. Instead of finding the LCM, I'm just going to cross multiply. Remember, this only applies if you have one fraction equaling another fraction. So for example, you might see an equation that looks like this. This is not one fraction equaling another fraction. This is actually two terms equaling one term there. Okay, so be very careful. It has to be in proportion form. Example, one fraction here equaling another fraction, okay? Versus here we have two terms, or here we have two terms equaling one term. These are not proportions, only these. All right, so back to business. So like I said, you don't have to find an LCM here. Even if you find an LCM, the solution will be the same. In this case, though, you can just jump to the chase and cross multiply. So I'll be like x times x plus 2 is equal to 8 times x minus 1. I love these types of fractions, fractional equations. So I distribute, and now I see it's a quadratic equation. I'm going to make my equation equal to 0 by transposing all terms. And we transpose by doing the opposite operation. So this is minus 8x plus 8. Cancel, 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 cancel. Now I'm going to combine my like terms. Oh, well, looky here. What do we have? We have a leading coefficient. I feel like we just did a problem that came up with the same thing. Yes. Anyways, so here I have 8 as my C, or my AC is 1 and 8, and it's a positive 8, but I have a negative second term. That means I can apply two negative factors that will still give me a positive 8, but when I add them, I will get a negative 6. So look like my two factors will be x minus 4 and x minus 2. So here I will yield, when I set each factor equal to 0, I will yield that x is equal to positive 4 and positive 2. And if you're not sure about that solution, you can always plug back in to check. Let's just do one more, just to drive it home. All right, so here we have a biggie here. We have this fractional equation where we can see a unique factor of x plus 4, x minus 2, and then we have a whole quadratic equation here that we'll have to put in factored form, which looks like an obvious difference of two squares because we can find the square root of both these terms and they're being subtracted. So that's x plus 2, x minus 2. So if you're not sure how I get this, you'll definitely have to refer to videos of factoring, special factor, or difference of squares. You shouldn't be at this stage of the game if you don't know how to factor. So here we go. Again, it's an equation. So we'll find our LCM here is obviously x plus 2 because you do not repeat the factors, and x minus 2 because they either have one of the LCM factor or both or all, right? We could say one or both. So we know by hindsight that everything will be multiplied by the LCM, right? I'll just make a note of that up here just in case some of you are still a little confused, right? Every term is going to be multiplied by the LCM because we want to have a nice linear looking type equation, which eventually we know converts into a quadratic equation because we're going to have an x squared term. So obviously here the x2 factor cancels, the x minus 2 factor cancel, and here the entire factor cancels, right? So we're left with x times x minus 2 plus 2 times x plus 2 equals to x plus 6. So I'm going to apply my distribution on this side of the equation. So that's x squared minus 2x plus 2x plus 4. And I'm going to transpose all terms so my equation could be equal to 0, right? What you do on one side, you must do to the other side, right? And it's equal in 0 because, again, it's a quadratic equation. I know I sound like a broken record, but this is things you have to tell yourself while you're working out equations so that you don't make any mistakes. So here, what's happening here, I can see my two x's are canceling out. And I'm left with x squared minus x minus 6. Right? No, I'm sorry. Here we go. We have a positive 4 term and a negative 6 term. So if we subtract these two and keep the sign of the greater magnitude, we have a negative 2 remaining. Beautiful. So now if we look at our AC here, it's just good old 2. Remember, when the leading coefficient is 1, we know by hindsight that we can cut straight to the chase and find our factors. So obviously a negative and positive factor will give you a negative factor as an end result. But if we were to treat them as terms, a subtraction would have to be involved. So this is actually negative 1. So we have to find two factors of negative 2 that when we subtract it, it leaves us with negative 1. So there's obviously a negative 2 and a positive 1 factor, right? So that's x plus 1 and x minus 2 equals 0. Set each equation equal to 0. And we'll see that our x is 1, right? Negative 1 and positive 2. And that's it, guys, for our fractional equation. I hope I did enough samples so you could catch on. If not, you know how to reach me. All right.